At the third time recording this is getting very annoying. All right. Optics. What are optics? Optics are a branch of light in which deals with the physics and study of light. You put on the Discord light mode. What happens? You get blinded by the light. That light study of that light is known as that optics. Now, what are types of optics? Optics, geometrical optics. This one scientist guy thought himself as a great guy and saw light as particles. Like the small atomic particles. Yeah, those were the particles of the light. Now, what are wave optics? This guy said, hell no, I'm not gonna select geometrical optics as particles. No. I'm gonna say light is a wave. Then this random guy, general knowledge, this random guy with a cat said, nah, you both wrong. Because light is a particle and a wave. It just light will behave differently when you see it. Light will behave differently when you don't see it. It's complicated, so we don't right, where were we? Yeah, let me just use a laser light. It's better, I think. Or it's not better. Alright, where were we? Yes, ray optics. Ray optics done, reflection done. We are not gonna dispute over some guy coming with his cat and saying that he will say that reflection of light and refraction of the saying that geometrical optic and wave optics are coexisting in the same thing. We don't gonna walk about that. No, and quantum physics, the most BS thing ever to be existed. Not gonna talk about this. Ray optics, reflection of light, refraction of light, dispersion of light. Oh, this explains this. This thing is so simple. A third grader would actually understand this. If you don't, you've delved too much in the Gen Z territory, not gonna lie. Now, rarer and denser molecules. What are rarer and denser molecules or medium? Gas. The thing Hitler used. Very far apart, just like the Jews now. Liquid. My bathtub. Very close but not close together as my kneecap, or solid. Simple. Basically, this is a medium. For example, this line, this is medium A and this line is medium B. So A and B, and if this is solid and this is liquid, this would be a denser medium and this would be a rarer medium. This would be a denser particle, this would be a rarer particle. This is so simple, I could understand it in threes. I teach to the 6th standard kid when I was in 3rd standard. What are you guys studying? Alright. Topic 1, reflection of light. First of all, let's talk about this. It comes in the exam and you should understand this. Ray. For example, you blow a torch. There are multiple rays of light. Yes, a ray of light. I know there was a cut right now. a ray of light is a single ray of light. These a single particle, a single ray. It's only says a single line. But for example, you see as laser light, that is also actually a beam of light. But you can say a very very fine particle of light is known as a ray, or basically the first unit, the second unit. Gram, kilogram. 100 gram, 1 kilogram. Something 1,000 grams, 1 kilogram. Yes, math sucks. So beam is a collection of rays. If you don't have figured that out, go to kindergarten and get a job. Alright, when light by traveling from one medium to another medium part of light, this is a definition. I'll dictate to it you right now. When a light ray traveling from one medium to another medium, then some part of light ray bounce back to same medium is called reflection of light. Don't get confused like me. Alright, let me introduce this smooth transition. Let's go. Waitashi. Alright, are you able to see what I am able to see? Doesn't seem to be on camera. Let me just use the other light. Now is it visible? Is it sukabalit? I just this, yeah, totally not. My luck is bad right now. Let me just. Alright, this is the light I got. It's a blue light. It's actually purple, but the blue light gets filtered, so it is. Let me just show you the actual color. Oh my god, you all would be just getting irate now. Oh, my eyes. Alright. Where's the Suka mirror? Alright. We got the mirror. Now see. The phenomenal. Let me just set up this thing. Alright. His camera is not catching this. I'm gonna quit my Alright. How could I show this? This is a mirror. Where is the who is the there it is. Asuka. What's it for? Right, I'm not showing there. Welcome to my messy room. Right. Yes, upside down is the correct one. You see this? This is called a mirror, you see, and This is called the flashlight, which was I review. I'm childish. Still, let's start. This is the incident ray. You won't see it because I've got the worst flashlight, but there is a incident ray here. If you squint your eyes, you won't be able to see it. You won't, let me tell you. Oh wait, let me try this. Wait. Oh, it works. It works. Let's go. So what I gotta do is smack these seats. So what could be the most alright, let me just there is a mirror. Alright. Okay. I don't know why I showed that to the camera, but alright. Now what you see, point A, the above point. If you can see it, you will know. The above point is a source. Oh my god, I'm gonna kill this below. Alright. This right here. And if you can see, this is the incident ray. It's a ray. Alright, this is a ray. Now this is the point of incidence, where the mirror is this mirror. Now if I touch both, what do you see? Perhaps an angle, perhaps. Yes. Is there an angle? Yes, there is. This is the incident ray, which is the starting ray. This is the reflected ray, reflected from the mirror. Alright. This. And now you see an angle. Yes, you perhaps see 3 points. Now what these 3 points are? This point, the incident ray, this point, the reflected ray, this point is the point of incidence. The midpoint, the 90 degree of the equal of these two lies the normal. It's an imaginary line, and it divides the incident and the reflected ray into two equal parts. Now, how does it divide into equal parts? Let's see. This is the incident and the reflected ray, as you can see. If this line, the thing from straight here, between these two, exactly between these two, would lie a normal. Now if I get this laser light closer to the normal, the angle will shorten until, yep, this happens. You see these two, they become one, and that's why it's brighter, by the way, or else it would not be a brighter. See this. Yes, perhaps you see it. Alright, now what I did was bring the incident ray close to the normal, which makes, as normal is divides the I and angle R into two equal parts, which is angle I means angle of incidence is equal to angle of reflection. You can see that the normal is still equal to still divides, or not divide here, but still is very very equal. If you know what I mean, you know what I mean. The angle of incidence here is equal to angle of R. Here's the second law. This, you see, alright. Incident ray, reflected ray. Yes. Angle of incidence, angle of reflection, and the normal lie on the same plane. What does this mean? If this is the mirror here, would this light escape to another parallel dimension? No, it wouldn't. Or would it go to the next? Oh my god, I'm having paranoia. Alright, the shadows are scaring me. Alright, so where was I? Yes, the second law. The second law states that these all three lines lie on the same plane. Now, if I focus the focus at a specific point, angle of I would be equal to angle of R, like that. Now that is it for the today's video. I'll just give you a summary to this. So what we studied about light being in the branch of optics. We studied reflection. What is reflection? I give you the definition. We studied normal, incident ray, and the reflected ray. We studied about the angle of incidence and the angle of reflection. Therefore, let me just show you a quick diagram of this, a very quick one. This is a mirror, this incident ray, this reflected ray. This would be the normal here. Yes. Now angle I, which is this angle I, angle R are same, and these two angles and this means incident ray, reflected ray, and the normal lie on the same plane. You can see these three meet at this point, and this is only in one plane and always on one plane. So angle I is equal to angle R, incidence equal to reflection, normal divides. No, don't leave this is not gonna come in handy later on. Angle I is equal to angle R, and incident ray, reflected ray, and normal lie on same plane. Why did I waste 21 minutes of my life on this? Well, I did not waste them. I just used them to make my advantage out of this, because, well, it helps me in this channel. So I'm not in this channel in my studies. So thank you for watching. We'll go deeper into this. This was just an introduction to the chapter, and if you thought this was complicated, wait for the snail's law. Alright, see ya.